Today we're going to be talking about adding and subtracting polynomials. So a monomial. We've already talked about monomials. A monomial is a polynomial with one term. And it can have more than one variable. So I could have 5xy squared. A binomial has two terms. The word bi means two. So I have two terms there. Trinomial. A triangle has three sides. A trinomial has three terms to it. So if your degree of a polynomial is 0, its name is constant. An example, 487. Just some number. I made up some random number. Okay, if you have your degree being 1, you are linear. Now, this doesn't matter how many terms you have, really, but if your highest degree is 1, it's a linear. So 4x plus 7. If your highest degree is 2, 3x squared minus 8x, that's going to be a quadratic. I'm going to say plus 9. Okay, it doesn't have to be 3 terms. I just wanted to add in 3 terms there. So if the degree is 2, a cubic. 7x cubed plus 4. Okay, cubic, the highest degree is 3. So if your highest degree is 4, so there's an example. It's called quartic. If your highest degree is 5 of your polynomial, your highest degree is 5. So let me highlight the highest degrees for you. Highest degree is 5. Highest degree is 4. 3, 2. We don't write the degree there. That's 1. Okay, and then for 6 degrees or higher, it's just a 6-degree polynomial. Okay, determine whether each expression is a polynomial, find the degree, and determine whether it is a monomial, monomial, binomial, or trinomial. Okay, so this is a polynomial. Yes, this is a polynomial. Okay, find the degree. So I look at the degree of the highest term. That comes off of this term here. So that is a linear. And it has 2 terms, so it is a binomial. Now here, determine whether each expression is a polynomial. It is. This b is a polynomial, so yes, we are a polynomial. My highest degree is 2. Technically, I have a degree of 1 there and a degree of 1 there, so that's also a degree of 2. So find the degree. My degree is 2, which makes it a kind of a quadratic. I think if we graphed this, it wouldn't actually look quadratic. And since I have 3 terms, it is a trinomial. For C, because of this 5d to the 4th at the bottom, this is not a polynomial. And then this next one, yes. My highest degree is 2, and it is a monomial since there is only 1 term, and I spelled monomial wrong. Monomial. Okay, so when you're writing polynomials in standard form, you have the leading coefficient, which is the coefficient of the term that has the highest degree. Okay, so writing it in standard form, you start with the highest degree, and then your degrees decrease in size as you add more and more terms. So write each polynomial in standard form, identify the leading coefficient. Okay, so for this first one, I have to look and see which term has my highest degree. That's this term here. That term comes first. Then I have my next highest term is the squared term minus 4x. My leading coefficient is 3. That's the coefficient on the term with the highest degree. Now this one's interesting. I actually learned something when I made up this example. I was kind of torn on what the highest degree was. So what you have to look at is each one of these individual terms here. Okay, the degree here is 1, the degree is here is 1. So technically that term has a degree of 2. I add those together. The x has a degree of 1, the y has a degree of 2, so you have to add those together, and that's a degree of 3. So technically that 8xy squared is my first term. Then I go to my 6xy, then 5y, then 12. And then my leading coefficient then is 8. So I actually learned something when I was putting this presentation together. I was very torn on that. Okay, finding the sum. All you have to do when you're finding the sum of something is you're just combining the like terms. So really this is just one big addition problem. So 7 plus 5 is equal to 12y squared. Then I have 2y minus 4, well, that is going to be negative 2y. And then negative 3 plus 2 is a negative 1. And we always want to write these in standard form. Okay, so highest degree to the lowest degree. Okay, so find the sum. Just another example. Again, when you're finding the sum, it's just one big addition problem. So any term that has a squared, 4x squared minus 7x squared, well, that's a 3x squared. And sometimes people like to cross those off. Hey, I've taken care of those terms. Now I have negative 2x plus 3x. That turns into an x. I've taken care of those terms. 7 minus 9, that's a negative 2. And again, this is in standard form, and it's okay that our leading coefficient in this case is negative. Okay, finding the difference. So what I like to do is I write out the first one, and then I distribute the negative. So I distribute the negative to the 9, distribute it to the 7, making it positive, and then to the 2y squared. Now, I just combine my like terms. I have 8y to the 4th minus 9y to the 4th. Let's say negative y. Cross those off. I've taken care of those. Now look for your next highest degree. Well, that's my 6y squared minus 2y. Those get canceled off. And then I have 7 minus negative 5y plus 7, so that is a plus 2y. Again, another difference problem. Just remembering, the big thing that I like to remember here is I distribute that negative inside. So basically it turns into an addition problem. So now I just combine my like terms. 6n minus 5n squared. Ooh, I didn't notice this. Oh, I made a mistake. I didn't notice this 11n cubed term. And I have nothing to combine that with, so that just stands on its own. And then, because I want everything in standard form, then I have my negative n squared. And then I have positive n squared. Man, get it together. Minus 2n plus 3. Okay? And that is my video on adding and subtracting polynomials, and kind of also an introduction to what polynomials are.